All right, so now we know how to describe this distribution. We know how to make predictions by plugging in X values for Y. We know how to calculate the residuals and make a residual plot. Okay? Now, we have this other variable that we're going to talk about here in regression, S. S is simply the standard deviation of all the residuals. So that's all that we have here is the standard deviation of all the residuals. S is going to tell us, on average, how far away was each of our predictions from being correct. The book says S measures the typical distance between the actual Y values and the predicted Y values. So S is just telling us, on average, how far away is each one of our predictions from being correct. So the larger the S, the further spread out our points would be about the prediction line. So it's just standard deviation. We're dividing by n minus 2 instead of n minus 1, but no big deal. We were not going to get into why that's the case right now. So again, S is just the standard deviation of the residuals. On average, how far off are we on our predictions? All right, so now we have this other variable, R squared. Okay. The calculator finds R squared for us. R squared is called the coefficient of determination. Makes it sound fancy, big long term. The coefficient of determination, R squared. R squared is simply R squared, just like it says. So for this R value of negative 0.815 we found for our price of our F-150, if I want to find out what R is, I simply take negative 0.81 and I square it. Negative 0.81 times negative 0.81 is approximately 0.66, somewhere in that neighborhood. R squared, the coefficient of determination. What does it tell us? Okay, R squared tells us the percent of the change in Y that can be explained by the change in X. It's not a percent. Right now it's a decimal. So after we calculate R squared, we'll have to take the decimal point and move it over twice. Okay, so R squared will usually be given to us as a decimal. We just need to know that we have to change it into a percent. This sentence that we're going to use for R squared is going to be the same for every regression problem we do. We would say 66% of the change in the price of our truck can be explained by the number of miles that we have driven. That means that 34% of the price of the truck is explained by something other than the mileage. What other? We don't know, because in regression, we can only look at two variables at a time. And certainly there are other things that go into the cost or the price of a vehicle. So again, R squared, the coefficient of determination, tells us what percent of the change in Y can be explained by the change in X. Again, remember that this is not a causation, it's an explanation. So correlation does not imply causation. R squared doesn't tell us that 66% of the miles on the vehicle cause the price. It's telling us can explain the price. So we're saying 66% or the miles driven explains 66% of the change in the price. 34% of the change in the price is explained by something else. We could guess all day what that something else is. The condition of the truck, what state it's in, what kind of rims does it have? Does it have anything extra done to the interior, or does it have a great sound system? Or we could go on and on and on. Regression doesn't look at any of that. It looks at two variables only. So we're saying for the coefficient of determination, R squared, the percent of the change in Y that can be explained by the change in X. How do we calculate R squared? Simple. It's R squared, R times R. R squared will always be a positive value because a negative times a negative gives us a positive, and a positive times a positive would also give us a positive. R squared will be given to us after we turn our diagnostics on our calculator. We will get R squared to come up. So if we go back and look at how we calculated the least square regression line, we went stat, calc, 8, which is linreg, a plus bx, L1, L2. We stored it in Y1, and then we calculated. And it gives us R and R squared. Okay? R squared is the percent of the change in Y that can be explained by the change in X. Very commonly asked question. They want to know, what does R squared mean? Now, probably just as important as all the calculator stuff that we've talked about is how do we read a computer printout? More than likely on the AP test, regression questions will come from a graph given to us and a printout. So here we're looking at a mini tab printout of the problem that we've been working on. Okay. Now, what's important to us is what's been highlighted here. We have a constant, and then we have a variable. Miles driven. The variable is always going to be the slope. The constant will always be the y-intercept. Pretty much everything we need is going to be under this coefficient column. For right now, we don't need any of this stuff back here, nor do we need this R squared adjusted. We'll never need the R squared adjusted. At the end of this book, we will go back and look at this standard error of the coefficient, the T and the P. But as of now, these are the only things that are important. So this mini tab printout is giving us the equation of the line. It's telling us that the price of the truck, the predicted price, I put a hat over it to make sure that we know it's predicted, is equal to 38,257 minus 0.16292 times the miles driven. That's what this printout's doing for us. It's giving us this regression equation. Oftentimes, it's much better to write the equation in words instead of variables. So what do these variables mean? In context of the problem, we're going to be asked over and over and over again to explain the slope in context. So we would say this negative 0.16292, for every 1 mile driven, we predict the price of the truck will, so for every 1 mile driven, we predict the price of the truck will decrease by 16 cents. So every mile we drive, we predict that the cost of our truck will decrease by 16 cents. Every single regression equation can be interpreted the same way. What does this slope mean? Okay. So, oh man, I just erased everything. So remember we had, it's all right. We had the predicted price. So I'm going to put a little hat above price saying, hey, I'm a prediction. The predicted price is $38,257 minus 0.16292 times the number of miles on the truck. Okay. How do we predict, or how do we explain what this negative 0.16292 number is? For every 1 mile, we predict the price will decrease by 0.16292 or 16 cents. Okay. And then what is this 38,257 number? How would we interpret that in context of this problem? We would say, oh, at 0 miles, the predicted price would be 38,257. Or we could say a brand new truck, we predict a brand new F-150 would cost $38,257. Okay. Very important that we can put this equation in words so that we can explain what the heck does this mean. So we're going to be doing that all year long and everything. What is the context of the problem? What does this mean in context? Okay. Oh, I predict it's going to be 27,524. Who cares? What's going to be 27,524? It doesn't matter if the problem doesn't have context. So again, the slope is probably the most important thing to be able to do here is for every 1 mile, we predict the price will decrease by 16 cents. Okay. Now, this Minitab printout also gives us some other information. You'll notice in the green box here that it's telling us R squared. Oh, so it's telling us R squared equals 0.66664. But you notice it doesn't give us R. So if R squared is 0.664, R would have to equal the square root of 0.664, okay? Which we saw earlier was negative 0.81 something. But the square root of 0.664 is a positive value. From R squared, how do we know that R is going to be negative? Either by looking at the line on the residual or on the regression, looking at the line on the scatter plot, the least square regression line, or remember that R must always have the same sign as the slope. Since the slope is a negative value, R must match that and be a negative value. So in the Minitab, they will not give you R. They'll give you R squared and you have to come up with R. A common mistake is making R positive all the time. Look at the slope. R's sign matches the slope sign. And the last important piece of information that we're going to get out of one of these printouts is this S value here. Remember, S is the standard deviation of the residuals. So in context of this problem, what does that mean? That on average, each one of our predictions was $5,740.13 off from the actual value. Each prediction on average was off by $5,740.13. So again, we need to be able to find the slope, the y-intercept, R and R squared, and S. Everything we need about a regression line is given to us in this one printout. So the constant is always the intercept. The variable, whatever the problem's about, is always the slope. R squared and S will always be given to us. From there, we can find anything that we need. Very, very important. Probably one of the most important parts of this chapter is how to read one of these computer printouts, because that's probably what we're going to be seeing on the AP test.